I take this chance to welcome you again in the series of sessions via our beloved channel known as EduElim channel. Yes, if it is your first time to visit our channel, make sure that you touch that red word known as subscribe. After touching the word subscribe, make sure that you click the symbol of the bell so that you get notification at any time when we upload a video in our channel. Today I am going to teach you concerning to the topic of logarithm. In the topic of logarithm, I am going to deal with a part of standard form or scientific notation. It is my expectation that from the starting to the end of my session, you will be able to determine, you will be able to know the way you can state the standard form for any given number. So you have to listen to me attentively from the starting point of my session to the end. Let us start with the meaning of standard form. What is a standard form? A standard form or scientific notation is a way of expressing numbers in form of a times 10 raised to exponent n, whereby n is any integer. It means that n can be 0, positive or negative. Also, 1 is less or equal to a, and a is less than 10. It means that the value of a may be from 1 up to the number which is less than 10. Let us see different examples of numbers which are expressed in their standard forms. Express each of the following numbers in standard form. The first number is 60. The second number is 2.846. A third number is 83. A fourth number is 9,627. A fifth number is 884.67, and a sixth number is 0.0062. So it is my expectation that via these 6 numbers, when all of them are expressed in their standard form, you will be able to know the way of expressing any number in the standard form or scientific notation. Let us see the solution for each number, the way we can express each of the given numbers in the standard form. The first number is 6. The standard form, a standard form for any counting number made up of a single digit a is equal to that digit multiplied by 10 raised to 0. It means that a times 10 raised to 0. So the answer for the given number, which is 6, will be 60 times 10 raised to 0. Now, why do we multiply it by 10 raised to 0? You have to know that when we take 10 raised to 0 is equal to 1, as any number exponent 0 is equal to 1. So 60 times 10 raised to 0 is equal to the one who have taken 60 times 1, which will be 6. So you have to keep in mind a standard form for any counting number made up of a single digit is equal to that digit multiplied by 10 raised to 0. The second example is to express 2.846 in the standard form. We say that a standard form for any number which is greater than 1 but less than 10 and having decimal point is obtained by multiplying that number as it is by 10 raised to exponent 0. Now, our number in the standard form will be equal to 2.846 times 10 raised to 0. A third example is to express 83 in standard form. We say that a standard form for any number which is greater or equal to 10 but with no decimal points is obtained by putting a decimal point just after the first digit from left and multiplying the resulting number by 10 raised to the exponent equal to the number of the digits after the first digit from left. Now you can see this is 83. Now it is true that 83 is between 10 and above. It means that it is greater than 10, as we can see. Now what we do, we put a decimal point just after the first counting number, which is 8. So after 8 we put a decimal point, and the next number and the next digits will be written as they are. So it will be 8.3 times 10 raised to the number which is equal to the number next to the first counting number, which is honorary 3. So it is the single number. So the number will be 8.3 times 10 raised to 1. And you have to remember, for all numbers which are greater than 1, the exponent raised to 10 must be positive, and negative for all numbers which are less than 1. The fourth example is to express 9,627 in standard form. This is the same as the previous example. Now, the standard form for this number will be obtained by taking 9.627 times 10 raised to 3. Why this will be the standard form for this number? Because we have agreed in the third example that if the number is from 10 and above without a decimal point, what we do is to start with the first number from left. After the first number from left, we put a decimal point, and after a decimal point, we count the next digits, all digits which are next to the first digits, and here we have 6, 2, and 7. So we have 3 digits. So this will be equal to 9.627 times 10 raised to 3, and this 3 which is raised to 10 must be positive, as the number is greater than 1. A fifth example is to express 884.67 in the standard form. Now, for the case like this, as you see, the given number, when the given number is greater than 10, but there is a decimal point between, now what to do? The standard form for this to be obtained, you will start by putting the decimal point just after the first digit from left. After putting that decimal point, what will be the next? You will be required to count the number of digits between the original decimal point and the new decimal point which you have put, and after counting the number of those digits, now you will be able to write the standard form of this number, and for this will be 8.8467 times 10 raised to exponent 2. It is raised to exponent 2 because the number of digits between the original decimal point and the new one is made up of 8 and 4. So there are 2 digits between these 2 decimal points. That is why we say that the standard form for this number will be 8.8467 times 10 raised to 2. The sixth example is to express 0.0062 in standard form. We say A standard form for any number which is less than 1 is obtained by putting a decimal point just after the first counting number from left and multiplying the resulting number by 10 raised to the negative exponent equal to the number of zeros positioned on the left of that first counting number. Now we can see in our example of 0.0062. In this number, the counting numbers which we have are only 2. It means that we have 6 and 2. 6 and 2 are the counting numbers which are within this number, which is 0.0062. So, according to the instruction of writing the standard form for this number, we will take the first counting number is 6. Now, after the first counting number, we put a decimal point. So it will be 6.2. After putting 6.2, we are told that we should multiply the resulting number, which is 60.2 times 10 raised to the negative exponent of the number, which is equal to the number of zeros positioned before the first counting number. And the zeros which we have are only 3 zeros. We have 1, 2, 3. So the resulting standard form will be 6.2 times 10 raised to negative 3. And you have to remember the exponent to which 10 is raised must be negative if the given number is less than 1. Thank you for attending today's session. I welcome you in the next sessions via our channel of Edwerim. And if you have not subscribed, make sure that you subscribe this channel so that you become the first to be notified when we upload any video via this channel. Also, welcome for more comments, especially concerning to today's session, and I will respond appropriately based on your comments. And you have to remember that your comments will make us to know the areas to make correction and the areas to make consistency. Have a nice moment.